Evening. I'm Spot On Weather meteorologist Matthew Euler. Welcome to my latest video. All right, so since we are now in the month of October, we're going to go ahead and I'm going to start talking about these teleconnections discussions again. Now, this is something I had put together yesterday evening, but I still feel like a lot of the material is still fairly accurate, actually. Not much change between yesterday and today, the 5th of October. So I'm going to go ahead and show you this this evening here, kind of show you what's going on with the latest teleconnections. We'll break down what these different teleconnections mean, and then I'll show you the European and the GFS Ensemble 500 millibar height anomaly forecast as well. Now look at the overall slide here, the title slide. Notice this chain reaction, okay? Whenever you get whenever you get all of this stuff going on, this is just a couple examples of the teleconnections, the Pacific Decadal Oscillation. In this case, we have a positive PDO because we have orange coloring and warmer than normal sea surface temperatures across the Gulf of Alaska down along the west coast of Canada and the US, colder than normal temperatures across the north central and northwest Pacific. That's a positive PDO. Of course, we have a negative PDO forecast for the upcoming winter. But you kind of see how things kind of kick in here. We're going to have a La Nina, but I just wanted to kind of show you, if we had an El Nino, how that atmospheric teleconnection will then kind of feed into a stronger than normal Aleutian low for sea pressure anomalies, and then you got your ocean decadal response here. So it's one big web of connections when we talk about teleconnections. All right, so let's examine the 500 millibar height anomalies. This was as of yesterday, 4 October 2024. Again, not much change really from 24 hours ago, so I feel this is still fairly pertinent to show you. All right, so we start off first. We have this. I'm going to go ahead and brief this this graphic from left to right, west to east, basically across the northern hemisphere. One thing I want you to realize is the oranges and the browns, those indicate above normal heights, which are associated with ridges. And beneath these orange and brown colors, you typically have more in the way of dry, fair weather and warmer than normal conditions. Whenever you see the green and the blues, that indicates a trough lower than normal height anomalies at 500 millibars. And whenever you see the green and the blue shadings, that generally indicates storminess and cooler than normal conditions. So let's go ahead and brief this from west to east. All right, so starting out here, we have upper level ridge west of Siberia, working our way eastward. We then have a strong upper level ridge. You really see it over the northwestern Pacific at this time. It's really standing out. 597 decameter closed high, upper high. So we got this very much anomalously above normal heights, and that is occurring basically above the atmospheric. This upper level height or higher height is occurring above this anomalously warmer than normal water temperatures out here. We do see a deep upper level trough, generally west of the Bering Sea, over the Bering Sea, west of Alaska. And then we see another upper level trough, generally off the west coast of Canada. We have a little bit of upper level ridging across the western US up to western Canada, out ahead of that upper level trough. And then we see a deep upper level low and trough over Hudson Bay, generally to the north of Hudson Bay as of yesterday. So you see the green coloring here. And then we have an anomalous, we're talking anomalously, this light brown shading here over Greenland. We have a really strong upper level ridge over Greenland right now. And then we have an upper level trough generally to the east of Greenland. A little bit of ridging going into the United Kingdom and the British Isles there, Ireland. And then we have a trough generally in the western parts of Europe into France. So all these waves, these are short waves on this particular chart. We're looking at 500 millibars, right? But all these various waves, they're all globally connected from west to east, whether we're talking Siberia, right on from west to east across the Pacific Ocean, across the United States and Canada, then across the Atlantic, all the way over to Europe. It's all connected. All right, so now let's examine the Mount-Julian oscillation phases and areas of enhanced convection. We see that the MJO is divided up into phases 1 through 8. So if we're looking as an example here, if we were to see convection over the Indian Ocean, specifically the Eastern Indian Ocean, we would be seeing MJO phase 2 and 3. If the convection or the unsettled weather was over the tropical areas here of the maritime continent, that'd be MJO phase 4 and 5. And then if we go closer to the international dateline here, we would have MJO phase 8. So this kind of gives you a geographic look at where these MJO phases reside. In other words, where do we see the enhanced upward vertical or rising air motion, and where would we see the clouds and the precipitation? Now, let's examine what the Indian and West Pacific Ocean satellite infrared imagery indicates. We do see, as of yesterday evening, we saw area of scattered convection across the eastern Indian Ocean, as well as up north of that area, east of India, there in the Bay of Bengal. So we do have some scattered convection generally across this particular area. And then over here in the right, we see a lot of scattered convection, these clusters of convection, where you see these clouds located across the equatorial Pacific Ocean. We have the clouds stretched out up here. This is an association with that strong upper level ridge. You can see that these clouds are clearly uh, going up and over the top of this upper level ridge. It's just so strong across the northwestern Pacific. You see a lack of clouds beneath the ridge here. So we have a lot of activity with the intertropical convergence zone still, a lot of scattered convection, scattered showers and thunderstorms into the Philippines and even into the South China Sea. If we look at the MJO temperature composites, this is for the months of October, November, and December. Blue shading here on the left-hand graphic indicates cooler than normal temperatures. Yellow indicates above normal temperatures. So if, for example, we were to go into MJO, let's say MJO phase 2, we should see below normal temperatures from the Gulf Coast up the mid-Atlantic and up into New England, generally in the eastern U.S. We would see above normal temperatures at this time of year with MJO phase 2 over the upper plain states and over the central U.S. All right, so what do we have in the forecast here? Let's look and examine the MJO forecast. This is the Jeff's V12. This runs out to October 18th. And notice what we got here. We have the MJO here in the early stages of October, sitting right in this position here, generally in this smaller inner circle, which means very much non-impact due to the MJO. I call it the null phase because there's really not much going on when it's in this smaller inner circle. MJO really isn't influencing much of our weather in the United States. So it's in the null phase in the small inner circle here, right on through the 14th of October, and then it pulls out, the MJO moves out into phase 5. And you see that here around the 16th or the 18th of October in the MJO phase 5. So this is according to the Jeff's V12 model. What would MJO phase 5 look like this time of year? It would be cooler than normal readings for the deep south, the Midwest, right to the mid-Atlantic. What about the other models for the MJO forecast? CFS V2 extended over here on the left, showing also that the MJO is in the null phase at the present time, and it shows the MJO coming out into weak phase 5 over time. All right, and then we have the middle graphic here. This is the European extended. This is going out through the 3rd of November. By the way, this one on the left went out to the 2nd of November. The European extended goes out to the 3rd of November. You notice what's going on here with the MJO. According to the European model, we see it kind of riding and straddling that null phase and then coming out eventually, rotating into phase 5, weak phase 5, and then weak phase 6, and then rotating back in to the null phase by early November. Over here on the far right, we have the Bureau of Meteorology. This is the BUM model, the Australian Bureau of Meteorology. This goes out to Halloween, the 31st of October. And notice this red line here with these numbers, 2, 4, 6. That is the 2nd, 4th, and 6th of October. And then you get even the 8th here. Generally, MJO is in the null phase in the small inner circle here before rotating out with this blue line into weak phase 5, 6. Even 7 here by the end of October before going into the null phase. What about the ENSO update? Let's take a look. We examined this NOAA Coral Reef Watch daily 5-kilometer sea surface temperature anomalies version 3.1, and you generally get the idea where you're seeing the above normal water temperatures in this orange coloring here and the maroon coloring here across the north central and northwest Pacific. We have a marine heat wave going on. What that basically means is we have anomalously above normal water temperatures in this part of the northern hemisphere. We do see a little bit of below normal readings in the blue coloring, below normal water temperatures across the Gulf of Alaska. We still see some above normal readings northeast of the Hawaiian Islands towards the Pacific Northwest. We see below normal water temperatures in the blue coloring across the equatorial central Pacific at the present time. And then we see well above normal readings for the water temperatures in the Gulf of Mexico, the Caribbean, as well as portions of the southwest North Atlantic. And it's really above normal up in off the North Atlantic here, south of Greenland. You guys see these temperatures here, and they're well above normal. I'm snapping my fingers because I have a couple spectators tonight on the video in the background here, and I hear some mischief going on in the background. It's my dogs here. So you hear me snap my fingers occasionally. It's because my dogs are kind of getting into some things, and just kind of keep an eye on them while I'm doing this video at the same time. All right, so we see now on the right-hand graphic here, this is a CDAS Nino 3.4 index. This is for October, yesterday, showing generally we have a 0.74 degrees Celsius below normal water temperatures in that Nino 3.4 region. So this is the water temperature anomalies in that Nino 3.4, according to CDAS, are indicating a weak La Nina. And again, we kind of covered where the rest of these warmer and cooler than normal waters were. One area I forgot to mention here is right in this location, off the west coast of South America. You see the blue coloring here? That's well below normal water temperatures there. And one other thing we want to talk about is, where these La Nina cooler than normal water setup really matters too, because whether we have an eastern base La Nina east of 150 degrees west longitude, or whether we have a central base La Nina west of 150, you kind of see the 150 line right here, that 150 longitude line right here. So you see it almost splits this cooler than normal water area right now. We'll have to keep an eye on these trends as we get through into the winter. Now this is the ENSO intensity classifications. This is your Nino 3.4 region here. Generally I'm showing you where it's at. It's a combination of Nino 3, which is this pinkish color, and the blue color is going to be Nino 4, so we call it 3.4 region. This is what NOAA uses to classify whether we have El Nino, a La Nina, or even a La Nada, which means ENSO neutral conditions. But right now, if we go back on this last slide and say, hey, we're 0.74 degrees Celsius below normal water temps in this area right here, well, that would indicate a weak La Nina right now, 0.5 to 1 degrees Celsius below normal. A moderate La Nina, on the other hand, would be 1 to 1.5 degrees Celsius below normal water temps in that Nino 3.4 region right in here. And then you have the strong La Nina would be between 1.5 and 1.9 degrees Celsius anomalies. And this really defines your Nino 3.4 region right here, okay? 5 degrees north to 5 degrees south, and then 120 degrees west to 170 degrees west. Let's look at the latest ENSO forecast now from the NOAA Climate Prediction Center. The blue vertical bars indicating La Nina, and over here on this vertical axis on the left, you see percent chance. This is the percent of this occurring. So here's our legend. Blue bars are La Nina, the gray bars are neutral conditions, and the red bar is El Nino. Well, here are your months that clustered in groups of 3: August, September, October, September, October, November, October, November, December, November, December, January. DJF is December, January, February, and so on. So what is the most dominant color bar on this forecast? Well, it's going to be your La Nina. So you see how tall these bars get. The taller these blue bars get, the greater or the higher the probability of La Nina occurring. And so right now, the NOAA Climate Prediction Center is still going with a 71% chance for La Nina conditions this upcoming winter. Intensity is projected to be weak. We look over here on the right. We're now looking at the This darker magenta line represents the average of the dynamical models, and the green dark line represents the average of the statistical models. So you clearly can see here that the green line here, the average of the statistical models, is much weaker with the water temperature anomalies. It's not as cold, in other words, and it's generally going to fall short of La Nina criteria. To be in La Nina, we have to be minus zero point 0.5 degrees Celsius or colder, below normal water temperatures, and the average of the statistical the models here, the average of those statistical models is not even getting to minus zero point 0.5. So that's really an interesting trend. Not to mention, this maroon line is a little bit stronger. Now that's the average of the dynamical models, and that is almost down to minus zero point 0.9 in November, December, January, then about minus zero point 0.7 to minus zero point 0.8 December, January, February, and then only about minus zero point 0.7 in January, February, March, and then that shows it going to ENSO neutral next spring. So really interesting stuff going on. 71% chance NOAA is indicating for La Nina this winter, and you kind of see the differences in the modeling here. Now, what really, really blew my mind this week is I went to the Australian Bureau of Meteorology website, and I wanted to share these graphics with you. I mean, this is the Nino 3.4 forecast for December 24 on the left, and then I have January 25 in the middle and February 25 on the right. So this is for the meteorological winter months. Now, these gray bars represent the forecast from all these different models. So we're looking at the Bureau of Meteorology model, the BOM, the CANSIPS model, the ECMWF, the European model. The JMA is your Japanese Meteorological Agency model. Meteo is France. NOAA, of course, is our own National Weather Service, NOAA. The UK Met Office model, UKMO. And this is the mean down here of all the models at the bottom, this darker bar. All right. Now remember what I said. You need to be at minus 0.5 degrees Celsius below normal water temperatures in that Nino 3.4 region or colder to be classified as La Nina. Well, look at these gray bars of each of these individual models. BOM, if we don't get to this blue area here, this blue shading on the left, that means we're not going to be in a La Nina. So the NOAA model is actually the most robust with going into La Nina conditions here. You have the JMA going slightly into La Nina conditions. You also have the UK Met Office model. Over here in the center, the forecast for January from all the different models, notice we only have two that are into this blue shading indicating La Nina. The NOAA model and then the UK Met Office model. Those are the only two that are indicating La Nina in the month of January. Every other model is indicating, including European, is an ENSO neutral. ENSO neutral conditions here. And then let's go over here to the right, showing February 2025 forecast. All of these models are in this white area. So basically, we're looking at ENSO neutral conditions. The overall official forecast, though, is for a weak La Nina to be present in December and January, and that's going to transition to ENSO neutral conditions by February. Now look at this. I also got this from the Bureau of Meteorology site. Now this is a model average. I'm showing you the ENSO forecasts here on the upper portion of the diagram, and then the bottom portion of the diagram showing the Indian Ocean dipole forecast. Look, everybody, this was just issued the 1st of October. Just issued. So if we look at, now this is the average of the international model forecasts, okay? So we look at the average of all those international model forecasts. October, we're still on that border between ENSO neutral and La Nina. In December, here in the middle, we are still in ENSO neutral conditions, basically riding that border again between ENSO neutral and La Nina. And then look over here, we also have this arrow pointing in the neutral conditions in February. Over in the bottom here, we're showing the average international model forecast for the Indian Ocean dipole. And you can see here, October is on the left. Then you have December in the center and February on the right. And you notice this arrow, this dark arrow, is the average of all those international forecasts showing a neutral Indian Ocean dipole. Now let's examine the quasi-biennial oscillation, the QBO update. QBO is in the westerly phase. How do we know that? Well, there's some soundings. We do some soundings from Singapore, and the balloon is launched and kind of gives you a profile with height all the way up on this vertical bar. With height, we have a temperature profile. We have the wind profile and the humidity and amount of moisture profile with height as well when these weather balloons are released. And look at where the blue solid line is. It's to the right. It's to the right of this tall vertical pressure scale here. And whenever you're to the right of this scale line here, you are in the positive values. That indicates that we have the QBO in a westerly phase. All right. And that westerly phase is expected to last through the upcoming winter. And what this means is, when I say westerly phase, is we have strong westerly winds. We have westerly winds over the equator in the stratosphere. Now, let's keep looking at things here. What does a westerly phase do for us in the wintertime? Well, research has indicated westerly QBO generally favors a stronger stratospheric polar vortex. But now we have an interesting situation going on, and I'll get to that here in a bit with the polar vortex. Now let's look at the Arctic Oscillation Forecast AO. And just as a review, a negative Arctic oscillation over here on the left, that in the wintertime would mean I have a lot of cold Arctic air coming down into the United States. I'd have a major trough generally across the Midwest and Eastern U.S. with a negative AO. I'd have anomalously higher than normal heights and ridging, higher pressure over Greenland and extending into the North Pole area. My Aleutian low would be located further west. So it's a colder, stormier pattern with increased risk for freezes in the deep south and along the Gulf Coast with a negative Arctic oscillation. Get a weaker jet stream and a more fractured polar vortex. Okay. Over here on the right, what happens when we have a positive Arctic oscillation? All the Arctic air remains bottled up over the Arctic, and we get more of a west to east jet stream, so much milder across the United States. More Pacific air in the winter. Stronger polar vortex as well, situated up over the poles. So let's look at the Arctic Oscillation Forecast. This is European EPS, 50 perturbed members. Green line represents the average of all the ensemble members, of all those 50 perturbed members. Notice here on the bottom we have, this is the first two digits represents the day of the month, so we're talking about October, and the last two digits represent the Universal Coordinated Time, or Zulu time. Overall, what we're expecting with this green line is we're expecting a negative AO right on through 13 October before things become slightly positive through the 19th of October with the AO. And we're having a weaker than normal polar vortex. In fact, I just read that this is the weakest early October polar vortex in the stratosphere in 40 years, since the 1981-82, well, it'd be October 81. So since October of 80, not 81, it's more than 40 years. It is 1981. I apologize. Yeah, October 81. This is the weakest polar vortex in early October since 1981. Now, let's look at the European EPS AO 50 perturbed member forecast. This is 46 days out in time to 16 November. Shows this green line a negative value. See that negative values here? How this green line dips into the negative territory even further. So we have a negative AO also on this particular model, becoming slightly positive before transitioning back to negative in late October and early November. Moving on now, NOAA Jeffs V12 AO 30 perturbed members. So not quite as many perturbed members here with the Jeffs V12 as we had with that European EPS. But still, nonetheless, we have a negative phase of the Arctic Oscillation AO through the 15th of October, and then near neutral conditions through the 20th. North Atlantic Oscillation NAO forecast, positive NAO phase on the left. What we have with a positive NAO is we have more cold, more sea ice up over Hudson Bay, and there's more colder air basically staying up to the north over the Arctic. We got a more west to east jet stream, zonal jet stream is what we call it. Milder air across the mid-Atlantic and southeastern U.S. Also warmer and wetter across Western Europe, including France, as well as the British Isles, England and Ireland right there. It'll be warmer and wetter than normal with a positive phase of the AO. We got NAO rather. We got a stronger North Atlantic jet stream west to east. And then over here on the right would be a negative NAO phase. Now we got blocking over Greenland, so a strong upper level high. We have warmer temperatures up in the higher latitudes. Here on the North American side of the Northern Hemisphere, we have a trough and colder and stormier than normal across the southeast and mid-Atlantic. We have this blocking high again across the central North Atlantic with a negative NAO up to Greenland, and then another dip in the jet stream here into Western Europe. Cold and dry across England, and then warm and wet across the Mediterranean with a negative NAO. So let's examine the forecast for the NAO European EPS 50 perturb members. This is quite a significant drop off around the 8th of October. We're deeply entrenched in negative for NAO. Then it climbs slowly up towards neutral. By the time you get to around the 12th or the 13th of October, and then that green line goes back up into positive territory. So we have a positive, potentially, NAO through the 19th of October. Looking at the European EPS, NAO 50 perturb members, 46-day forecast, showing a sharply negative NAO. I'll show you the upper level charts here to back this up here in a little bit. But generally, we see the green line kind of straddling, going slightly positive, then dropping back negative again late October through early November. Moving on now to the Jeffs V12, the NOAA Jeffs V12 NAO 30 perturb member forecast, showing a negative NAO, deeply negative, the 7th and 8th, 9th of October. And you see this climb then up to neutral conditions right around the 13th to 14th of October, and it lasts right through the 20th. Moving on to the Pacific North American PNA forecast, what happens here with the PNA and why do we care? Well, with a positive PNA, we get increased chances of below normal temps across the eastern U.S., and we see an upper level ridge with a positive PNA across Alaska and the western portions of Canada, as well as a ridge over the western U.S. in general. We have a trough across the Midwest to the East Coast with a positive PNA. With a negative PNA, we have a flip-flop in the pattern. We have increased chances with a negative PNA of above normal temperatures across the eastern U.S., and then we see a trough across the same areas that had the ridge. So we see a trough in western Canada, western U.S. with a negative PNA, and we see downstream ridging across the southeast and mid-Atlantic. So what's the forecast? European EPS PNA forecast, 50 perturb members, showing a negative phase briefly of the PNA, but it doesn't last long. Look at this green line, the average of all the 50 perturb members of this ensemble forecast. You see the green line going well up into positive territory here by the 7th, 8th, dips slightly closer to neutral by the 10th, but then it jumps right back up to strongly positive, right on through the positive, really all the way through the 18th of October before becoming more neutral. Looking at the European EPS PNA 50 perturb member forecast, this is 46 days out to around the 16th, 17th of November time period, showing a negative phase of the PNA briefly, but now that PNA is climbing up to a positive 2 value, dips down a little bit closer to 0, that neutral line, and then rises right back up, right back down, and then neutral. Generally, from late October through middle November, the PNA looks to be neutral. And then the NOAA Jeffs V12 PNA 30 perturb member forecast, negative initially, 4th, 5th, and then it climbs up into positive territory and remains positive. I mean, strongly positive, the 13th to the 14th of October, and then comes back down towards neutral conditions there, 18th to the 20th of October. Looking at the Eastern Pacific Oscillation EPO forecast, negative EPO here on the left, and look at what you get with a negative EPO. You got a very strong, anomalously high height center, or a ridge across the Gulf of Alaska from the Northeast Pacific, a huge ridge. Beneath that, you have this low just to the east of the Hawaiian Islands. And then you, on the front side of this strong upper level ridge with a negative EPO, you get colder air to filter into the northern plains, Midwest, and sometimes that spills into the East Coast. Over here on the right, positive EPO, what does that do for us? Well, it produces a fairly mild pattern, more of a west-east, highly zonal jet stream configuration across the United States, and it keeps all the cold air well to the north. And what happens is, in the Pacific Ocean, we look at the positive phase of the EPO, we have low pressure in the Gulf of Alaska, just south of the Aleutian Islands, and we have higher pressure to the south, generally stretching across 20 degrees north latitude in the vicinity of Hawaii. Let's look at the forecast now. European EPO, 50 perturbed members, shows a positive phase of the EPO. Now let's go back. Remember what we said about positive? That means we got a low in the Gulf of Alaska and higher heights or higher pressure beneath it, and a milder pattern for the U.S., okay? That's what a positive EPO would indicate. Now notice with time, that positive EPO through the 15th of October then goes closer to neutral after that. European EPO, 50 perturbed members, 46-day forecast, positive phased EPO again, okay? And then it drops down closer to neutral. Really from late October through middle November, it's pretty much neutral, the EPO. And then no adjust V12. Okay, wait a minute now. Disregard this slide because this is the PNA again. So I apologize for that. I meant to hit EPO for that one. So I tell you what, these slides, it takes a while and you're constantly copying and pasting slides. So please disregard this right here. Wow. All right, we'll move on now to the stratospheric polar vortex update. This is the latest GFS forecast. Now, we're in early October right now, so, the stratospheric polar vortex is normally not that strong anyway right now. It's going to start increasing the wind speeds associated with that vortex as we continue in through October and especially November. The winds will become much stronger typically. What we see right now, what I'm showing you is two graphics. This is both GFS forecast. Well, not really forecast. The forecast is on the right. This was the current situation as of yesterday, Friday, the 4th of October, 2024. Now, where you see the peach colors, that indicates warmer than normal temperatures in the stratosphere. Where you see the blue coloring, that indicates colder than normal temperatures in the stratosphere, okay? This is a ensemble mean temperature anomaly chart. So blue colder than normal, peach warmer than normal. So yesterday we had warmer than normal conditions. Temperatures in the stratosphere, generally in Alaska, that Pacific side here, up into the Arctic Ocean. And over here on the right is the forecast now for the mean temperature anomalies for Friday, the 18th of October. So 2 weeks into the future, we still see that above normal stratospheric temperatures across Alaska, above Alaska, and the western portions of Northwest Territories and Western Canada into the Arctic. The European forecast for the polar vortex, very similar, a little bit stronger with the warming yesterday in the same general areas north of Alaska into the Arctic Ocean. And then over here on the right is the forecast, stratospheric polar vortex. This is your temperature profiles. Again, in the stratosphere, 10 millibars, showing above normal temperatures in the stratosphere, generally over Alaska up to the Arctic Ocean, even over onto the, let's see, that'd be getting closer to the Siberia side. So bottom line here is we do expect some weak stratospheric warming. Now, why do we look at the temperature anomalies in the stratosphere? Why do we care? Because if it's warmer than normal, that indicates, warming stratospheric temperatures indicate a weakening polar vortex. All right, here's another great example from Z.D. Lawrence. This is from StratObserve website, stratobserve.com. Now, this is the forecast showing, these are the different models, the different color lines represent the different models, but generally these are your zonal mean zonal winds. And so you notice over time, these winds, zonal mean zonal winds, are forecast to strengthen slightly as we get deeper and deeper in October. This is a normal thing. Over here on the right, we see these are the temperatures in the stratosphere in degrees Kelvin. Notice how these lines kind of go downward over time towards 20 October. That indicates cooling temperatures in the stratosphere in this case, according to this. Now, we have something interesting going on right now in the stratosphere. It's resulting in a weaker than normal stratospheric polar vortex. We got a very active solar cycle right now, and believe it or not, that is partly to blame why the stratospheric polar vortex is so weak. Westerly QBO and this active solar cycle is resulting in an increased production in ozone, and with ozone molecule O3, the incoming solar radiation is absorbed by these ozone molecules up in the stratosphere. That results in warming with extra ozone up in the stratosphere. You're going to have warmer than normal stratosphere typically. So that's kind of keeping things weak right now. We'll have to watch the trend in the ozone as we continue to move in through the fall. Now here is the latest upper level chart forecast. This is a European ensemble, EPS. Up here in the upper left, again, the color scheme again for everybody to understand at home. Green and purple coloring and blue are lower heights, lower than normal heights, associated with storminess and cool temps. And then the browns and the orange coloring indicates above normal heights, associated with milder surface temperatures and drier conditions. So yesterday, here upper left, EPS, showing the 500 millibar height anomalies, generally showing a weak ridging over the mid-Atlantic up to New England yesterday. We do see a deep upper level low here over northwestern Hudson Bay. And then we do see another low troughing off the west coast of Canada. We see a lot of peach coloring yesterday across the United States, which is indicative of slightly above normal, higher than normal heights. Over here on the right is the forecast now for Monday, the 7th of October. We got a trough now, a negatively tilted shortwave trough digging from where it used to be up here near Hudson Bay. It's now moved southeastward. And we see heights now beginning to increase or rise across parts of Idaho, Montana, and Wyoming. This is a ridge is building in this general location here, upper level ridge, while this trough is going to deepen over time. Look over here in the bottom left. This is the forecast for, this would be Thursday, 10 October. Look at how solidly green things are, well below normal heights across New England. But that trough extends further south into the mid-Atlantic by Thursday, the 10th of October. And then upstream from that trough, we have much darker orange coloring indicating even higher than normal heights. And we see this ridging here. One other feature I didn't even mention was up here in Greenland. We have a negative North Atlantic oscillation. See this brown coloring here? We have a very strongly negative NAO. And you see where that upper level high is. It's right over southern Greenland. And it's going to remain in that general area right on through Thursday, the 10th of October. By the time we get over here in the bottom right-hand graphic, the forecast for 13 October, it weakens. That ridging weakens over Greenland. But we still have this ridging associated with a positive PNA pattern generally across the western provinces of Canada. And whenever you build the heights over the western portions of North America, you're going to get downstream troughing into the eastern U.S. Let's take a look now at the GFS ensemble V12 forecast. This was yesterday in the upper left, very similar to the European. Not much difference, right? Because it was real time yesterday. We still have that negative NAO showing up over Greenland, abnormally higher than normal heights. And we still have that deep closed low, upper low there, and troughing over Hudson Bay. We have general west to east flow across the United States in this case. A little bit of ridging there along the eastern seaboard. Over here on the right, Jeff's forecast for Monday the 7th of October, showing that shortwave trough digging now into parts of southeast Canada and Michigan. We see that ridge starting to build now across western North America. And the bottom left here, forecast for the 10th of October, things get quite chilly along the eastern seaboard. The first real refreshing breeze of fall coming in, generally from Maine right on down to the mid-Atlantic by Thursday. We still have the higher than normal heights across central Canada, but we still have this negative NAO, higher than normal heights, upper level high height center there across southern Greenland. And over here on the bottom right, we show the forecast. Things kind of get a little flatter in the flow. The main jet stream axis is situated over southern Canada, right along the northern U.S. border here by the 13th of October. That deep upper closed low now has moved out south of Greenland and replaced the higher than normal heights that was there. We also see a trough moving into the northeastern Pacific by this point in time. So final thoughts on tonight's video. I'm happy to present these teleconnections discussions again. Let's go ahead and break down what we just examined. The MJO is in the null phase through 15 October. What does null phase mean? Non-impactful weather for the U.S. Then it's forecast to rotate into phases 5 and 6. The null phase favors no significant weather impacts to the U.S. weather. It's really not much of a player right now. Phase 5, however, if it moves into phase 5, it would favor cooler temps across the eastern U.S. Now, if it were to continue into phase 6, that would favor milder temps across the eastern U.S. I think some of the longer range modeling is really favoring this phase 6 MJO because you're seeing some rebound in temperature, some moderation, after a couple chilly shots of air hit the eastern U.S. And so neutral conditions are present across the equatorial eastern and central Pacific. Now, if we're just looking at the Nino index itself and the atmospheric response, we're still technically in ENSO neutral conditions. But the water temperatures, according to the CDAS, are within the criteria of a weak La Nina right now. So water temps say La Nina, but ENSO index and even the SOI, the Southern Oscillation Index, are not quite to those La Nina levels just yet. The sea surface temperature anomalies, we talked about warmer than normal waters across the Northwest Pacific, North Central Pacific. We also saw warmer than normal waters, well above normal water temperatures across the North Atlantic. We saw cooler than normal waters located over the equatorial tropical Pacific, and then off the west coast of South America. Now, models are indicating a negative AO phase through 13 to 15 October, right in that period, staying negative. Then a near neutral phase, a negative phase of the AO, the Arctic Oscillation, favors colder temps across the eastern U.S., underneath or beneath higher pressure and warmer temps across the higher latitudes of the north. The neutral phase of the AO favors near average temps and a more zonal west to east jet stream. Models are also indicating a negative NAO, North Atlantic Oscillation, through 13 October, then near neutral to slightly positive through 20 October. Negative phase of the NAO favors cold temps across the eastern U.S., with more of a blocking ridge over the northwest Atlantic into Greenland. Neutral phase favors near average temps and a lack of blocking. Positive phase favors warmer temps across the eastern U.S. Models are indicating a positive PNA, Pacific North American pattern, through 18 October, and then neutral conditions after that. The neutral phase of the PNA would just favor near average temps, more west to east jet stream configuration across the U.S. as a whole. Positive PNA favors below normal heights or troughing and colder temps over eastern U.S. And that's what we're probably going to, looks like we're going to see that through the 18th or so. And then if you had a negative PNA, you'd have a flip above normal. I'm sorry, no, we're still talking positive PNA. But the positive PNA, you also have that upper level ridge across the western U.S. and western Canada. Models are indicating a positive Eastern Pacific Oscillation, EPO, through 15 October. That then neutral conditions. Positive EPO favors upper level trough over the Gulf of Alaska, Northeast Pacific, and milder temperatures from the northern plains to the East Coast with a positive EPO. And then models are indicating a slight gradual strengthening of the stratospheric polar vortex as those winds strengthen. Zonal means zonal winds strengthen through 20 October and cooling, slightly cooler stratospheric temperatures. And this is quite normal this time of year. It really is. A strengthening vortex is normal. And then overall assessment, teleconnections, we're looking at a negative AO, a negative NAO, positive PNA, and a null MJO phase for the foreseeable future. This favors cooler than normal temps across the eastern U.S. Primarily these three, negative AO, negative NAO, and positive PNA, all favor troughing in the eastern U.S., cooler than normal temps. The ENSO neutral conditions technically are still in place. Lots of uncertainty with the ENSO forecast, as I showed you, as we head closer to winter. Will we see a weak La Nina? Will we see an ENSO neutral winter? They both could be on the table. And I also believe right now the strongest possibility this upcoming winter is going to be for a weak La Nina and then going to ENSO neutral late winter. I really believe that. I am actually examining all the past winters that fit this criteria, the weak La Nina, then ENSO neutral. High latitude blocking is occurring currently across the North Atlantic with a negative negative NAO, excuse me. In the western North America, we have higher latitude blocking with the positive PNA. That favors cooler weather for the eastern U.S. As far as our friendly MJO, Mount Julian Oscillation, no major impact from it are expected in the short to medium range through middle October. All right, we'll continue to watch all of these teleconnections. I certainly hope you enjoyed this very detailed breakdown of the teleconnections. My plan is to do these teleconnection videos once each week. Okay, so hopefully I'll be able to put these out towards the end of the work week each week. That's my goal. And we can kind of watch this as we go through the fall and winter, and you can really see how these teleconnections impact that long wave pattern, where those troughs and ridges set up, where the fair weather and the mild weather sets up versus a stormy and colder weather, excuse me. That's all I got for now, everybody. And until next time, take care and God bless everyone.